Hi, I'm Juana from Altom, and I will be hosting this webinar. Thank you for joining. Before proceeding, I want to let you know that you can ask questions during and after the webinar using the link in the description. I have Ru here that is going to tell you about the worst bug she has ever found. This webinar is also an introduction into some of the concepts you'll learn in a BBST Bug Advocacy course that we are organizing in April with Cam Kainer. So I'm handing over the mic to Ru.
Hi, everyone, and welcome to the webinar. I'll start by telling a little bit about myself while you still see my own video, and then I'll switch to sharing my slides, and I'll continue with the story of the worst bug I ever found. So I'm originally from Romania, but I now live in Helsinki in Finland. And I work as a tester at Altom at the moment, and I'm also one of the partners in the company. We started in 2008, but I've been a tester since 2002. And the story that I'm going to tell you is actually from my first job as a tester. I'll get into that a little bit later, but even my first job was working with mobile apps and mobile devices. So I started testing mobile apps before I actually owned a mobile device myself. I'm still doing a lot of mobile testing now. I do a lot of also mobile automation and even some mobile app development. I'm also one of the instructors for the BBST classes that we teach in collaboration with Cam Kainer and Becky Fiedler. These are a series of online courses, and I think most of the ones that have joined the webinar tonight have probably at least completed foundation out of the series of BBST courses. In this webinar, I'm going to talk a lot about some of the concepts that you will learn about in the bug advocacy class. And this is why it's related to a story about a bug that has kind of had a big impact on my career. Let's say that way. So I think I can start sharing my slides. Try to do that now. Okay, so the link for asking questions is also going to be here at the top on every slide, and it should be also in the description, but just in case, you'll find it there at the top. As a brief summary for how the presentation will go, I'll start with telling you the story from the start of my career, and then I'm going to talk about the lessons that I've learned from that one bug. I'm going to mention RIMGEN, which is a guide that we learn about in bug advocacy for investigating problems and for improving the way we describe the problems that we find or report them. And then I'm going to also talk a little bit about signal detection theory, with the idea of trying to understand how and what influences the way we find and then the way decisions are made about fixing bugs in general. So starting the story, like I said, this was during my first job as a tester. I'll try to give you a little bit of the context about the company and my role. The company was doing actually outsourcing software development for a company from the States. They were growing really fast, and they were actually hiring a lot of people very fast. They also had, basically, they were always hiring developers, but they had a policy that everyone that started in the company was supposed to stay as a tester for 3 months, work as a tester on different teams. And the idea, and then just after those 3 months, move on to become programmers. And the idea there was, first of all, that by doing that, everyone who started working there got to basically know all of the products and understand the the ways of working and got to know all of the teams. But also the idea was that they basically started doing testing, offering also testing services, but they didn't really have a testing team. So this was a way to also get a lot more people as part of the testing team and doing testing. There was just, I think, we had one test manager. There was the one constant person in the team, and then a few others that had decided to stay on as testers. This is also something that I decided to do after the 3 months. I realized that I really loved doing testing. I thought the test manager we had was actually also quite encouraging, and she was really excited to see that I was interested in learning more about testing. And she was, for example, the one that bought me the first book on testing that I ever read, and that happened to be Lessons Learned in Software Testing, where Kem Kainer is one of the authors. And that book really made an impression on me. And you know, in that sense, looking back, I'm really excited that we get to work directly with Kem Kainer now, thinking of how I felt when I was reading the book that he wrote. So I decided to stay as a tester. I really loved it, and I think I'm quite lucky to have basically started my first job doing something that I really love doing, and I'm still doing this many years later. I think it was, so the company was mostly developing mobile solutions, so to say, or products. In the US company was basically developing some bigger enterprise solutions for synchronizing data between different Exchange servers and Lotus Notes servers and so on, but also synchronizing, for example, Outlook accounts and emails and tasks and so on to mobile devices. And the team in Romania, I think, was mostly working on the client side, so the mobile side. But I think it was about a year and a half into my first job when I was kind of assigned my own project. At first, it was just me doing the testing, but later on, there were 2 of us working on the testing. And this was one of the first components that we were developing in Romania that were not on the client side. We were developing one of the server-side components. But all of the server side or the backend side was developed in the US for the other components. So we didn't really have a full solution. The full solution was actually very complex and very complicated. So we had all of the other components, we had them simulated on our side. And the testing process was difficult in a way because of mostly because of the installation, which was very, very time-consuming. I had to always start clean by installing a few Exchange servers and then configuring data for them and Outlook accounts and then importing data for them. And so there was all this process before we got to the point where I could check the synchronization of all those servers to some client-side components as well. So the bug that I want to tell you about is, sorry, I had some slides skipping. Okay, so the bug was a crash that I would see in the logs every now and then during this long installation process. So every now and then, it wouldn't happen all the time. At first, I think I saw it only a couple of times and didn't really know what to think of it. But it looked like one of our component would crash for some reason, or I could see an error in the log regarding one of the, I think it looked like some kind of integration problem. But because the whole installation seemed compromised and because I wasn't sure that it was really a problem in our product or a problem with all of the simulated components that I was testing, I would restart the installation and then not see the problem again. And I didn't report this right away, mostly because I didn't know if it was really something that I had done to not install things properly or in the right order, or if it was a real problem. But also because as testers in the company, we were really evaluated at that time on the kind of like the number of good bugs that we found, and any invalid or bugs that the developers couldn't reproduce would kind of reflect badly on our performance when we were evaluated. And I mean, this was just one reason for me to not log the bug. It's not something, I mean, I think this is not the focus of this webinar, but it's really something that influenced my decisions along the way, and then afterwards the developers' decisions as well, I think. The other thing that was happening, so eventually, because I saw the bug a couple of times, I decided I would report it anyway, because I could see, I didn't know how exactly to reproduce it, but I could see that I could reproduce it if I tried a couple of times. So I wrote all the steps and reported it in the bug database. And then the following build, I guess the developer had tried to reproduce the bug, and he said it didn't happen on his environment. So he closed the bug as unreproducible, and said that it's probably related to either my environment or the simulated components that we were using. And I tried the new build again. I saw the problem at some point during installation, and I reopened the bug, saying, okay, I still see it. Here's what I do with these steps. I can reproduce it. Every now and then it was intermittent, but still I felt like I had a pretty good understanding of how to reproduce it. And then the other thing that was happening in the company is that all of this, I would reopen the bug, the developer would again say, I couldn't reproduce it, and try to come up with some reason why I would see it and he wouldn't. But all of this conversation would happen only basically in the bug database. We didn't really talk directly, or I didn't go to investigate this with him, mostly because due to the fact that the vast majority of their testers were in the company were very, very junior. There was also a policy that we shouldn't really kind of disturb the developers every 5 minutes with questions on how does this work, why does this not work, and so on. So there was I think I could have, but I still decided to just continue the conversation over in the bug database. So because we went back and forth like this quite a few times, build after build, we were doing at some point, as we were getting closer to the release date, we were doing, we had meetings where we would go through the open bugs, and this became an issue that kept being discussed in our bug triage meetings, basically. And in one of these meetings, we had the CEO as well there. We had those meetings in the CEO's office, and this was not really unusual. He was a former developer, so he was still quite involved in the day-to-day meetings, and especially close to release date. So, you know, he asked each of us, both me and the developers, about the bug. The developer kept saying it's not a problem, it's something that I probably do wrong. I was saying he's probably just not trying hard enough, and we had this kind of like a back and forth argument, also face to face. At which point the CEO decided to defer the bug, and not really close it yet, but kind of say we're not going to fix it. It's probably not reproducible. Let's defer it for now. So I didn't really argue that very much, and of course the decision was taken also with the idea that we had very little time left, a lot of bugs still to fix, and the release was always, you know, coming too fast and with not enough time. But we did have the release, and you know, of course, as it happens in production, we heard a couple of days later, mostly because the installation really was very complex and took a long time at the customer side as well. We heard that one of the three main customers that the company had couldn't use the product at all. And this is when, you know, there was a lot of meetings back and forth trying to understand what was happened. And both me and the developer were basically called in again in the CEO's office to kind of discuss what was happening. And while the developer was looking at the logs, I remember that the CEO was asking me for an explanation of why I hadn't found the bug. And like I said, this was my first main release, or the first release where I was the main person responsible for testing. And which means I was really very junior. And I didn't expect this. I didn't realize that, I was going to be blamed for things that we didn't find during testing. So I became very defensive, and I was trying to figure out explanations for that, or more like excuses. And so the situation was getting tenser and tenser, and the developer had found the error in the log, so I was trying to go and look at it as well myself. And the moment I saw the actual problem in the logs, I realized obviously that it was the same bug that we had discussed earlier in the CEO's office. And I went from being very defensive to being very arrogant, I guess, or very happy to have been right. And I went into I told you so mode. And I was so excited about the fact that it wasn't my fault. It was clearly the developer's fault, or the CEO's fault, or someone else's fault in that situation. And again, as I got happier and happier, the developer was more and more worried, and the CEO was more and more annoyed. And then something happened that actually turned this into the worst bug that I ever found. This is so far really just the story of a bug that was hard to reproduce, and then it showed up in production again. I think we've all had more than a fair share of those. This is not what makes this bug special. It's what happens next. So the CEO was saying that he feels like we've already wasted a lot of time on this bug, in the first place discussing it, and then afterwards. Now it's become a major problem for a customer, and it's going to cost a lot of money, and so on. So he believed that one of us was responsible for this, and it was either that I had not reported the bug well enough for the developer to know how to reproduce it, or that the developer was, I don't know, not good enough to investigate it and figure out what was going on. So of course, it was late in the night. For some reason, these things always happen late at night. And the CEO said that we were going to go right there and then to the developer's desk, and I was going to try to reproduce the bug on his environment. And if I could reproduce it, then the developer would be fired. And if I couldn't, then I would be fired, because it meant I couldn't really write a bug that was well enough written to be reproduced. So this part here is what makes this the worst bug I ever found. And I went from being defensive to being happy and arrogant and all that, to feeling something that I don't think I've felt since then in a professional environment. I felt like there was no good solution from there on. I felt like I was put on the spot in a way that I didn't expect, at least, or I didn't want to be put in ever again. So I think my entire career since that moment, I've tried to avoid this from ever happening again. So to give you some kind of like a closure to the story, we did go to the developer's desk. I had to do the steps twice, and I did reproduce it on his machine. And he wasn't fired on the spot. We went home that night late as it was, and then the next day he actually had to start working on a fix and figure out what was happening. But he was let go later on, like in about a month, when there was like a bigger redundancy exercise within the company. So I did feel somehow responsible for that, even though maybe it didn't really have anything to do with that incident anymore. And what I want to get at, so now that you know the story, is that what I've learned from that is something. It's related to what I could have done better in that story. I don't think we need to talk about bad company policies. I don't think I mean, obviously the CEO's reaction and in general attitude was not the best one. It doesn't show good management skills, but that's not what I want this to be about. I think I want to talk. It was very important for me to understand back then what I should have done to avoid such a situation, because there was really a lot of stuff that I didn't do very well myself. And I realized that, but I think maybe at the time I didn't also have the skills to know how to do better. I have a list here of things that I think I should have done better, or that I didn't do well. I think the main problem was that I kept reproducing the bug over and over again without trying to find out what was the underlying problem there. I didn't try to investigate it more. I just kept trying to reinstall so that I wouldn't waste more time. I didn't ask the right questions. I didn't give the right information. I think I had a chance in the first place when we were discussing with the CEO in the bug triage meeting to explain why this is important, and I didn't. I didn't suggest that we would use a real environment in the States. You know, and on top of that, I really didn't have the right attitude. I didn't have the right attitude as I was trying to replicate the bug, and as I was assuming that the developer is just not good enough to reproduce the problem, rather than maybe he's overworked himself and so on. And then I didn't have the right attitude as we were trying to figure out where the problem was when it was already in production. So putting all of these things together, I realized that I had to get better at I could find bugs, but I had to get better at reporting them. This was a problem with the way I had reported that problem, not with the problem itself. So I think this is where the bug investigation guide that I mentioned in the first place would have been really helpful for me. And I struggled with this for quite a while to figure out how to get better at this. And then during when I first read the bug advocacy materials from Kim Kainer, I found this so-called RIMGEN guide for investigating problems that has changed the way I look at problems and the way I write them up and describe them to others or report them in a bug database. So RIMGEN stands for replicate, isolate, maximize, generalize, externalize, and use a neutral tone. And each of these are steps that you can try to do once you've found the problem. Now that you've found it, you need to try to go through these steps to make your story about the problem or the way you describe the problem better. And some of them might be useful and some of them might not be, depending on the case. But typically, especially with bugs that are hard to reproduce, having this guide and going through these steps is just extremely practical. So I'll try to go through each of these one by one. First one being replicating the problem. And you'll see here we have these drawings you'll see them for each of the steps in the guide. They are made by our colleague Levi. He made actually one for each of them, and we turned them into postcards at Altum that we sometimes give out at conferences and whenever we have a stand somewhere or as promotional materials. I think they're really great, and they're very suggestive for each of the steps. So hopefully you'll enjoy them as well. So the first step is to replicate the problem. And we all know this. We find a bug, we need to put in the steps to reproduce. I did this very well in my bug report. In fact, this is all I did. I just kept doing this over and over again. It was useful in the first place, but from there on, I did not bring any new information to the table whenever I said I can still reproduce it. But this is the first step once we see something. Once we can replicate the problem, what we need to do is try to isolate it. And it's one thing to find some list of steps, and it's what's essential is to find the shortest list of steps. And this is what helps us isolate a problem. And this is something that I really didn't do at all for my bug. What I was missing is, so I could say, if you do this 5 times, all like the entire installation steps, then at some point you'll see the error in the logs. But I didn't know the critical condition. I didn't know what was really causing that error. And it turns out, the developer investigated the problem, and it turns out it was a racing condition. So our component was trying to use one of the other components, server-side components, before that was actually ready and running. Very simple problem, as long as the moment you know what it is. Our component was never supposed to be, I think, up before the other one, but because I actually had kind of my process for installing was so well. I knew it by heart, and I had the steps in my installation process very well defined. I would do this, then that, then that, then that. At some point, something would happen at the wrong time. So this is why I would always reproduce it, and the developer couldn't. And it was basically, he couldn't reproduce it because he didn't know the critical condition, what was really causing the problem. And this, my list of steps, even though it was okay and it eventually got you to the problem, should have been a lot shorter. It should have said, install this component before our component. That was all. I didn't do that at all. So this is really something very useful and very simple that you can try to do when you're trying to work with difficult bugs. Another thing to try is to maximize the problem. When you do follow-up testing, once you found the problem, you shouldn't really stop there unless it's very obvious. You should try to do follow-up testing to find like the most serious version of the same bug. Again, in my case, I just said there's an error in the logs. I didn't really follow up on that to finalize the installation and see that nothing would work. None of the syncing between servers would happen. This would be, basically a showstopper for our customers. Then you could, besides maximizing a problem, you can try to generalize it. A lot of the problems that we find as testers are corner cases. And a lot of developers, I think, don't like corner cases because no one's ever going to do that, and this is so unlikely to happen, and so on. But the moment we can try and say, this is, uncorner our corner cases and generalize the problem to not just this one value, but this group of values, or not just this one system, but all of these systems, then the problem becomes a lot stronger and becomes more important, and it's more likely to be fixed. Another thing that I didn't do well at all was externalizing the problem. That's another step that you can try to do. This is about explaining who would care about this problem and why they would care. Again, I didn't talk to the guys in the States. I didn't explain that this could totally block a deployment. I didn't do anything. I was just in my own test environment and didn't look at anything around that would have been affected by this. And then the last step in the guide, even though it's not another thing to try, it's like an overall thing that you should try to do as a tester, is to always use a neutral tone, both in your bug reporting and in your general interaction of dealing with the problem. And this is something that I fail at totally. I actually often fail at this. I try very hard, but I very often get either very excited or very annoyed by something, and then I think I know better than everyone. And so this is something that will affect everyone's kind of view of the problem that I'm trying to describe. It takes away from the bug, and it makes it more about me, or it puts the wrong, it stresses the wrong issue. That's one thing. And then the other thing is that, of course, a developer that feels like you're judging them because they don't have the time to fix something is not going to be that interested in actually spending the time to investigate it, and so on. So, blaming people, placing the blame on someone, like I did in the when we were trying to look at the logs, and when I was saying that it's clearly the developer's fault because you couldn't reproduce it, that never helps. And anger and also doesn't help at all. But this is not just about the way I reacted in the face-to-face interactions, but also in my tone in reporting the actual bug in the bug database. That can also have, if we write bugs where we say, oh, this is an easy fix, it's not something for us to necessarily estimate, and plus there's no need to make someone feel like we know how to do their job better. So this is something that I've learned since, to be careful to how I phrase my reports. So since then, this guide really helped me to be a better tester, I think, overall, because if my bug reports are better, then I think I am a better tester overall. But if we look back to the bug and the story, there were a lot of decisions that were involved in the whole process of handling the bug, and from both my side and the developer side, and then the CEO side. And for example, I decided to report the bug, even though there was a risk that it might reflect badly on my overall performance report later on. I decided not to talk to the developer. We had a rule about, a policy about that, but it wasn't a strict rule. I could have talked to him, but I didn't. And then, I didn't spend time investigating it. I didn't insist that it should be fixed. And at the same time, on the other side, the developer didn't take it necessarily seriously. He also didn't spend more time investigating it because he also had way too many other things to do. And the CEO decided not to fix it with all the information that he had. And he kind of also didn't ask about its implication, but decided to kind of trust the developer over me, mostly because he was also more senior and had more experience with the actual product as well. So these are just probably some of the decisions, but some that I kind of thought about to put down. And I think what all of these decisions have in common is that they were made in conditions of uncertainty. And by that, I mean that we couldn't have known beforehand if they were the right decisions or not. In retrospect, we can go and say, yeah, I was supposed to report the bug, that was good. But at that time, I couldn't have known what the right decision would be. And this is where I want to start talking a little bit about signal detection theory, which is used in psychology when we want to measure the way humans make decisions, especially under these conditions of uncertainty. And the main idea there is that we are not the whole process of making decisions for humans is very subjective, and we're not just, we don't just take the input, process it, and come up with the right answer without making any judgments about the information that we get. And to maybe explain this a little bit better, I'll take the signal detection. I'll take an example. Signal detection theory refers to the way we as humans decide to report that an event has happened or not. So if we think about driving under foggy conditions, as a driver, we need to decide whether there's something on the side of the road or not. And we need to decide also how far it is. We need to know, should we brake or should we not brake? And we do all of these. We decide on this based on our visual capabilities, which in this case are, they be anyway conditions of uncertainty because we're not that good at seeing very far ahead. But in this case, they're even more uncertain because of the fog. So under these conditions, when we try to detect the event of, for example, a reindeer being on the side of the road, this is something that's very, very common in Finland, in Lapland. The weather is always like that. And there's always the risk of reindeer on the side of the road. So in this case, we have 4 possible outcomes at any given moment. Either there is a reindeer on the side of the road and the driver doesn't brake, and that's called a miss. We missed the event. If there is one and we do brake, we do see it, that's called a correct detection, or a hit, but in this case, it's really not a hit because we do not hit the reindeer. Then we have a false alarm when we brake, when we just think there was something on the road, but there really wasn't any animal on the side of the road. And then there's the correct rejection when there's nothing, we don't brake, we just keep driving. So at any given moment, these are the 4 possible cases. And it's very easy to see how that kind of translates to a tester testing an application and trying to detect bugs. So at any given moment, there might be a misbehavior in the product that the tester doesn't see or doesn't report. That's considered a miss. If we do report it in the bug database, that's a hit. We could have a false alarm when we basically report something that we think is a problem, but really wasn't, or it's either according to spec, or we just didn't understand what had happened. That's a false alarm. Or we can have a correct rejection. This is most of the time when everything's working okay and we don't report anything out of the ordinary. So this is very easy to see as a translation, but then the interesting part is that the same thing basically applies to the decision to fix a defect. So whenever we have a defect, the person deciding on it, if it really is a problem that will affect a lot of customers, if we decide to not fix it, that's a miss. If we do fix it, that's a hit. We might have a false alarm when we fix something wasn't really such a big problem, or the bug wouldn't have affected many of our customers. So we probably shouldn't have fixed. So that's a false alarm. And then again, we have a correct rejection when there's nothing to be fixed and we decide, and we don't fix anything. So in that context, if we look at my story, the bug that I found was a hit, basically, because I have found and reported a real problem. But when they looked at it, both the CEO and the developer, they thought it was a false alarm. So based on that, the CEO decided to not fix a bug, and that was basically a miss. So just to give some context on how we can kind of categorize the events of finding and fixing a bug, and how we perceive them as the person making the decision to report a bug or fix it. So looking at these decisions, they're all made under conditions of uncertainty, and they are all subject to our own biases. And this is the interesting part of signal detection theory that I also learned about in the bug advocacy class, that really made me just understand my own behavior and my own biases better. So bias is a predisposition that we have as individuals towards one outcome over the other. And this is for example, it's a very big problem or known problem in science or scientific research. And if you look for experimenter bias, that's something that's very much researched and talked about. So just to give an example, if you think about a researcher that wants to, or someone who believes that water is the next cure for cancer, when they start a research project to kind of test this theory, they themselves, that the researcher is biased towards the kind of the positive outcome. He wants the water to really be a cure for cancer. So because of this bias, he's more likely to see results that support this theory. So his research and the results of his research are not going to be objective. They're going to be biased towards his preferred outcome. This is a real problem. We don't know how to not be biased. So the only thing that we can do in a situation like this is to be aware of our own biases and try to kind of do something to balance that in the opposite direction. And in scientific research, for example, a very common thing to do is to take a partner for the research who does not believe in your theory, or who has a different theory. So, for example, the researcher that is who thinks that water is the cure for cancer should probably take a partner who, for example, believes that not eating meat is the cure for cancer. So that other person is more likely to see events that support his theory, but together they might be in a more balanced situation where their biases kind of cancel each other out, let's say, or the results of a study that's done like that is not as subjective as one where just one person is observing results. So the problem with this, knowing that we don't know how to not be biased, is that it's hard to, even if we are aware of our biases, there's not much we can do about it, and unless trying to bias ourselves in a different direction. And this is something that we can do, and we can probably do to other people as well. We can bias them or try to influence them so that they kind of have a different preferred result, for example. And preferred result is just one of the main biasing variables. We talked about that. There's also the perceived probability of an event that influences our bias towards an outcome. So, for example, in the in the picture that we saw with driving under foggy condition, in Finland, for example, because reindeer move in herds and they have the same they do the same tracks all the time, it's kind of easy to know where they would cross the road. So very often you have a sign that says beware of reindeer, and because you see that, you know that it's probably in a place where reindeer often cross the street. So the perceived probability of a reindeer being on the side of the road is a lot higher. And just because we see that sign, we're going to think that we see more reindeer, even though there might not be there. And this is the what we want to happen, because we don't want to hit reindeer. So then it's good to think that it's more likely to happen. We want to have more false alarms in this case than missing the event and crashing with a reindeer. The other thing that we can change is so one of the other biasing variables is the expected consequences or the impact of an event happening. In the same example, if we think about instead of a sign that says be careful of reindeer, we could have the sign that says school nearby, and be careful with children. So again, this changes the impact or the consequence of an event happening. So we might be even more careful and brake even more often and have more false alarms, just because we think that there might be a child running across the road, and we want to avoid not seeing that. And then, of course, we can also influence the importance of the task or the perceived importance of the task. There's a big difference between just driving to the grocery store or driving an ambulance in an emergency case. So the way we perceive the importance of the task might impact our how much attention we pay to other events. So we might miss a lot of the events that are not relevant to the task that we are doing right now. So using these or considering these biasing variables, I think there's a case to be made that we can manipulate bias by influencing these variables. And I think there's a way, whenever we talk about that, like manipulating people, it's, you can do it in a constructive way, or you can do it in a very risky and maybe totally unpleasant way. And I think in the case of my story, we were trying to go for some kind of mission impossible. We were supposed to find all the possible bugs, all the valid bugs, but also not report any invalid ones. We were kind of influenced into this by the fact that we were being evaluated based on the number of valid and invalid bugs that we find. At the same time, we were supposed to not report any invalid bugs, but also don't miss any either. And this is something that's very risky, and I don't think this is possible. I think, it's possible, but I don't think it works in a way that is constructive and that can keep people motivated. Instead of doing that, I do think that there's a way to influence or kind of manipulate your own biases or your team's biases if you're a test manager in a way that is helpful for the team and the testing activity at a specific moment, and that is constructive in general for the testing process. So, for example, I think there's a way to basically bias people to find more bugs. We could, at a specific time in the project, we might really want to find many bugs. Usually testers are motivated to find bugs. This is their job, and usually that's their preferred result or their motivation. But sometimes we want really as many bugs as possible because we're, for example, in integration phase. We know we've finalized implementation on a lot of features, and we have a sprint where we now kind of integrate everything, and we all need to kind of focus on finding all the possible problems. And to do that, we can either say that to ourselves or to our team, explain the reasons why we want that. So we basically explain the consequences and the impact of our actions. or we can organize bug contests and encourage, really literally encourage people to find as many bugs as possible. So to kind of work on the preferred result or motivation. We can work on the perceived probability of bugs being found in the code just by telling ourselves that so many components have been changed that it's very likely that we will find a lot of problems. And just by thinking that we will find more problems than we would if we thought that, oh, okay, everything's been stable for a long time and we're not going to find anything anymore. So when we want to find more bugs, we could do that. We could use these techniques to kind of influence ourselves and be aware of our own biases. But what's important to understand is the moment we want more bugs, the moment we want basically more hits, we're going to have more false alarms. There's always this balance. So if we want to find as many bugs as possible, we need to be okay with the fact that we're going to have a lot of invalid or deferred or cannot reproduce or not important at the moment bugs. This is something that we cannot have both. And at the same time, at a different time in the project, like I said, maybe we're towards the end, we're towards a release. We maybe have weekly meetings with customers directly to discuss all of the problems that were found in the current sprint, let's say, and we might be really, really interested in not reporting invalid bugs because that will be very time consuming and will waste a lot of time, both from our side and from our customer side. So that might become, for example, very expensive. So we can again try to kind of bias ourselves towards not reporting any invalid bugs by trying to understand why, trying to understand the difference between different phases in the product. We're still testers, we still find bugs, but we need to focus on finding the only valid ones, the important ones, let's say. Of course, the probability, like I said, if we think that the product is more stable, we think it's less likely to find bugs. We can also kind of encourage informal communication or talking directly with developers. That typically means we're going to know about problems, or we're going to tell the developers about problems before they're actually reported, so we don't need to report that many and so on, and that by default will mean less invalid ones. And of course, we can also just train people to understand the importance of the task that they are doing, and also tell them that their decision of logging a bug is really trusted, and based on that, the customer meetings might be very effective, or they might take a very long time. So working on the importance of a task that you are doing at a certain moment. But again, once this is the direction that you want to influence yourself or your team, you need to be aware of the fact that you're going to have more missed bugs. The moment we say we don't want any false alarms, that means we're going to have a lot more misses. And this is something that we need to kind of be okay with. If we want to go that way, then we need to accept the fact that we might miss some of the bugs. If it's important to not spend time investigating ones that are not valid. So this is the key here. I think this is the way to do kind of to influence yourself or work on kind of being aware of your biases and counter bias them, let's say, is to understand the balance between these misses and false alarms and how they relate to one another. So this was mostly about how we can use the biasing variables to improve the way we find defects or look for defects. But I think there's also a way to, and I think this is also something very interesting that I learned from the bug advocacy class. There's a lot of interesting ideas on how the bug reports that we write also bias the people that decide on fixing them. So the CEO, in my case, really was probably biased by the fact that the bug was reported by me. I was a very junior tester. It wasn't maybe very well explained. It was just a bunch of steps and do that 3 times and that's all. So the quality of that bug report really probably biased the CEO towards trusting the developer more than my bug report. And I've really learned since then that as a tester, your own credibility and your own reputation as a tester does wonders to the kind of bugs that the kind of bugs from your list of reported bugs that get fixed or not. I think one of the main things is the quality of the bug reports. That really helps, and the way you investigate a problem to really find its core root cause, let's say. And in both of these cases, I think RIMGEN and the bug investigation guide that I mentioned really helps. It's really practical and gives you very clear ideas of what to try to improve both the bug report and the way you investigate it. The other thing I think that matters for the decision to fix a bug or not is learning when to give up and when to not give up as a tester. I think in my case, I should not have given up so easily. I had the chance to make my case, to convince the right people that the bug was important, and I did not. I gave up very easily. I said it can be fixed later or looked into later. But a lot of the times testers, I think, and I've done that myself since then, I fight too much as well. I don't give up early enough. I think no one likes that one tester that fights for every little thing, even though they might be not that important, because it's like crying wolf too many times. Then one time you'll have a really important bug and no one's going to believe you that really is important. And it's the same with estimating the severity or the impact of a bug accurately and not exaggerating the problem. It's the same thing. If you always exaggerate, or if you always misestimate or overemphasize how critical a problem is, you're going to lose your credibility, and people are always going to think, oh, you always say it's such a big deal, but it's not. And the one time when you want that to matter, it might the decision might be, well, we don't need to fix that. The tone, I've talked a lot about that. The tone of your bug reports really influences the decision to fix them or not. Sometimes they don't even need to get to. Sometimes the tone might influence the developer reading it. Sometimes it might influence the person deciding on whether to fix it or not. I think it always matters. And the last point basically that I want to make about this side of how we can influence decision making is about the concept of using friends with pickup trucks. We don't need to really have everything ourselves. And as I know many testers that are basically experts at everything, and it's very easy for us to think that because we represent the user, whatever we do, a user might do, and that's the ultimate kind of right answer for everything. But I think there's way better ways to do that. I've wrote bug reports like that myself, and I've actually seen quite many that say, for example, this is just bad design. Some feature works in a certain way that is really just bad design. We're not experts in design. We're experts in testing and exploring applications and reporting problems. So we might be right that might be really bad design, but we're not designers, so it really helps to just talk to a designer about that problem, explain it to them, get their opinion, and put that in your bug reports. Like add the relevant information, but also add the relevant sources, because you're much more likely to get where you want to get to when you have kind of the right sources. It's a bit like with writing a good article that's well backed up by science or articles that are credible. The same way your bugs can be more credible when they have opinions and suggestions from the right experts. So having people that can be your friends with pickup trucks in other teams and in other levels of expertise is really, really helpful for your bug reports as well. So these are the main things that I thought about touching regarding the story of the worst bug I ever found and the lessons that I learned. And to summarize them, I think there are 3 different kind of ways to look at it. First of all, as a tester, I learned that my reputation and my reports really influence the bug fixing decisions, and the quality of my reports still is really important, and can make me a good or a bad tester overall. And as a test manager, I've learned that it's very useful to understand how to motivate your team, how to kind of influence their ways of bug hunting and just testing in general in constructive ways, and try to work on their motivation rather than try to put them in situations that are like my mission impossible situation. And maybe the most important thing is that as a team, we kind of all have the same goal. We don't necessarily have a goal as testers or as developers or as product owners or so on. So I learned that fixing a bug that you shouldn't fix is almost as bad as not fixing a bug that should have been fixed. So our goal as a team really is not to fix all of the bugs, but really is to fix the right ones. And to get the right bugs fixed, you need to give people the right information so that they can make as good decisions as possible. So, thank you. I think I'll pass it on to Juana now for the questions.
Thank you, Ru, for telling us about the science behind reporting bugs. And I would like to ask all the participants, if they have questions, can you please add them in the page that is linked in the chat. So in the chat you can see, or in the description of this webinar, you can see a link. So if you add there your questions, Ru can answer them. And while waiting for the questions from participants, I wrote a few questions myself while listening to Ru's talk. So Ru, for you, a question from me.
Sure.
I was curious if you can give me an example about a good practice that you've seen applied in your current project about the influencing biases. So have you noticed like people trying to influence biases in a constructive way in the current project, for example?
My current project is maybe not the most typical one, but I can give an example that I haven't mentioned in the presentation. So I'm working on a project where we develop a lot of software that's used for proof of concept. So there's a lot of prototyping, both hardware and software wise. So I work as both a tester and a developer in that team. And my role as a tester really is to or looking for bugs in that kind of a setup is more about finding problems that block the show or block a demo. And my testing usually needs to really look for the positive side. So this is one thing that I try to do, and I'm not the only one doing testing. We typically set up some environment somewhere, and then we try to kind of use it in the way we would use it in a demo, because we would want to demonstrate the concept that we're building. And what we try to do is always think of positive actions. You don't try to find problems, you always try to avoid them. So this is something that we constantly need to remind ourselves. And we do that. I think I have one colleague that I work with quite closely on these. We find ourselves in situations where we see a problem, and at least I immediately kind of jump on it and try to find out more about why it's happening. And then I'm reminded by my colleague that we're actually trying to figure out how to avoid it altogether, find the path that will avoid that problem altogether. So it's a different paradigm altogether to the way we test, and that is something that we need to kind of influence ourselves or each other to remember to do.
Okay. Another question that I have is somehow related to an observation that I have. I've noticed that people perceive themselves as like they are good enough at reporting bugs. So as testers, this is one of the main deliverables many times, the bugs that we find and report. And what would you say to people to encourage them to work more on these bug reporting skills that are like involved in producing one of the most important deliverables?
I think I would say I've seen in my own experience, I've seen in a lot of companies that the main training that you get for bug reporting as a tester when you come onto a project is the template for reporting bugs in our company, which usually means just these are, you have to include the steps to reproduce, the expected result and the actual result in some form or other, plus maybe attachments and videos and so on. This, just giving someone a template is not enough to help them report a bug well. So I think going beyond that and trying to explain what kind of information is important in your context. People look for different types of logs. People look for, like, the information that you provide along with that is really depends on the context of the company. I also think that a lot of people nowadays, it's very popular to just includes a video recording. It's basically, now you can see it, there's nothing else to add, everything's well described because you can see what's happening. But if you think of the time you spend just watching and trying to understand what's happening in the video, and sometimes they're not very clear, that's not enough as well. So I think trying to go beyond the template is really a very good practical advice. Yeah, and then using RIMGEN for me really gave me good insight on what I can try. Not all of the steps might be useful in every case, but some of them will definitely help you improve your report. And also, it's not just about reporting them first time, but trying to improve them, or when you see the same problem again. I like to say that it's whenever you visit a bug because you've seen it, you should try to leave it better than you found it. Try to add something that's useful, that improves the existing bug. So that's also something that I think is a good practice to have in general.
Okay, thanks. So when we decided to change to this solution for the webinar, we had a slight worry about using the chat from YouTube, because it requires or it requests from people that want to post something to create a channel, which means an account in YouTube. So that's why we provided an alternative. And we were a bit worried that it's hard to follow this process of adding questions. So that's why I'm thanking Françoise for addressing the first question. And so thank you, Françoise, and nice to meet you again, this time as part of the webinar. And Françoise is asking, if you want to bring junior testers with low experience to this guide, is there a part that is easier to start with, or can we do an iterative process? What would you say, Ru?
I often think that I think people learn in different ways. I can speak for myself and from my own experience. For me, it always helps to see examples of how others have done it. And then also kind of maybe see the same thing applied to my own work. This is just generally about how I learn to do something new. I think in general, if we're talking about someone who's really junior, just getting them to trying to replicate the problem part and then trying to isolate it is the first two steps that I think are essential in reporting a bug. I don't know if, again, it depends on the person, and this might work for some people better than for others, but you could take one bug report, either first, maybe not the junior's report, but someone else's. Take a good example and walk through it and explain why it's good and what you appreciate in it, what information it has, and then take a not so good example and explain what's missing from it, and maybe try to improve it together with the junior tester. And from there, you can move to actually analyzing a real problem together. I think coaching very often helps, showing people how you would do it and kind of work with them to get them to be more and more comfortable with the process. In the bug advocacy class, we actually practice this in the assignments. So the class is 1 month long, and we actually look at a real product and we test it, and we kind of go through the steps from the RIMGEN guide and try to improve existing bug reports, basically. So this is also a way to practice in an environment that's not work related, or where it's safe to really practice. I hope that answers the question.
So if there are any other questions, please try to add them in the Q&A section that we've provided in the URL. In the meanwhile, I will have another quick question from Ru, for Ru, and then if there aren't any other questions, then we will close the session. So I was curious, Ru, if you have now a preferred step from RIMGEN that you enjoy applying besides replicating. That that was the starting point at the beginning of your career.
I like. I personally really like the. I always try to uncorner my corner cases, so that's one of my favorite things. I think this is something that I find immediately makes the bug stronger, or visibly, so everyone can see how, oh, all of a sudden it's no longer just something that happens on my machine because I use boundary values. So I really like that. I think that's a really powerful one. But different ones work for different bugs. A lot of the times, you know, I've seen different steps working in different cases. I would still think uncornering the corner cases is my favorite one.
Okay. Another question from Nico. Some hints to isolate a bug?
That's quite difficult, I think, and it's difficult because it depends so much on the type of problem. Trying to, I think, well, you get all the information that you can, gather all of the logs, try to learn how to parse logs very well, working on improving logs like from a development perspective. Having really good logs, I think, is always improves testability so much. So this is something that I always use a lot, logs. Of course, those logs are different in every case. I also I've tried many times successfully to look for different bugs that are very similar to mine, like actually looking for someone else's reports or stuff like that is similar to mine, and that might actually give me some clues as to what's happening there. And then, of course, trying things like minimizing the number of variables that change, from trying to keep these things fixed and only modify one thing at a time to try to figure out, does this cause it, does that cause it, and trying to go step by step to really verify what could be the problem. And also, I think trying to, I often have theories about why a problem occurs, and I like, just like with testing in general, it's very difficult to think of things that would disprove the theory. So I very often kind of find myself being convinced that that's the reason, but then turns out it's something totally different. So don't fall into that trap. Kind of try to always, when you have a theory and think this is the problem and you think you've isolated it, try to run tests that disprove that theory to make sure that you're not being just fooled by your own what you think the problem is. I think that's what I can come up with now.
Okay, Ru, I don't see any new questions. Maybe you can give us a few details about the BA course.
I've just added the slide now with the upcoming classes that we have. So we have an upcoming class now in April, 8th of April to 5th of May is the Bug Advocacy class. To take part in that, you need to have completed successfully the foundations class, and we also have the schedule for that. Out of the existing, out of the courses in the BBST series, BA Bug Advocacy is really my personal favorite. I really enjoyed both the materials, but also the practical stuff that you do, the actual bug investigation that you do. So I totally recommend it. Of course, biased as I am, because I'm also teaching the courses and really like the materials in general.
Okay.
I think we have another question from Françoise.
Yes, in the chat.
Yes.
The question says, has this guide changed the way you design your tests?
I don't think it has necessarily changed that. No, I think I would say not necessarily, no. Only it's just about the tests that I designed specifically for kind of addressing the problem that I've already identified. Then I, of course, try to either do follow-up testing or maximize or generalize the problem, but it's specifically the tests that I do for a problem rather than, generally speaking, test design.
Okay, so thank you, Ru. No more questions for now. If there are any questions, you can write to us and we will reply by email. And I have to thank you, Ru, for being willing to stay that late to talk to us and answer our questions. And I hope to hear you in a new webinar or a different one. So this is an invitation.
Thanks. It was good to be here tonight. So.
Okay, and thanks to all that joined and had patience until the end. And so again, if you have any questions that you were not able to write in the chats and in the options that we offered, please write to us. So thanks again and have a great evening. Bye-bye.
Thank you. Have a good evening.